All right, good evening, eighth graders. What you don't know is I just finished recording a video to to explain your homework for this evening, but whenever I got finished recording it, it wouldn't save. So that video was very detailed, very good, and I'm not sure how this one's going to turn out. I'm a little bit frustrated. All right, so today is March 28th. It's Friday, and we were learning about converting length, weight, mass, capacity, and time today. Right? Weight and mass are pretty much the same thing. Don't tell your science teacher I said that. They're not the same because mass is the amount of matter that something has, and weight is what it weighs here on Earth, right? Your weight will change, right? Your weight on Earth is different than your weight on the moon, but your mass on Earth is the same as your mass on the moon, right? So in science, they typically use mass, and they say things using mass. Um, they'll say it's a lot more important than it really is, but weight, weight, mass, kind of the same thing. It is different. Definitely for science is different, but kind of the same thing. Anyway, back to math class. Here on page 225 in your textbook, we do see a couple of measurement conversion charts. Do not use these charts. I explained in class today that even though these charts have lots of different, very precise conversions, I don't want you to use these charts because there's some conversions that are on these charts that are actually not on your reference sheet. Right? Your reference sheet has the conversions that you can use on FCAT because you can use your reference sheet on FCAT. Right? So I'm going to leave this up just for a second so that you can see these conversions. If you don't have this reference sheet at home, just know that there is a reference sheet in the back of the book that you may use that has the same conversions on it. But I'll leave this up so you can pause it at this time and use it if you need to. Remember that conversions within a system, you use these conversions up here. Over here is our customary to customary conversions. Over here is our metric to metric conversions, and then here are our time conversions. Um, Conversions between systems, if we're changing from customary to metric, we will want to use these conversions here. And if we're changing from metric to customary, we want to use these down here. I did demonstrate in a couple of classes that there is a difference if you use the, like, for example, cups to liters conversion right here. If you're going from customary to metric, of course you'd use cups to liters. If you accidentally use liters to cups, it may not matter that much. The difference will be very small unless we want not exact amounts, but unless we're doing larger amounts. Like 1 liter, it might not matter much, but maybe 100 liters it would, right? And it'll definitely show up as a difference when you're rounding to the nearest hundredth, or so use the correct ones as on homework. Definitely use it on the correct ones on FCAT. There will be some differences that show up there. The differences are small when we're dealing with little, small amount of units, but it gets larger when the more units we use. So make sure you're using that. Now, again, don't use these conversions. There are some conversions that are a little bit different than what we have on our reference sheet. It's the same, but it's different. For example, like centimeters to inches. All right. Our reference sheet says 1 centimeter is 0.39 inches, and here in the book it says 1.34. So this is more precise, but even though it's more precise, I want us to use our reference sheet because we'll be using our reference sheet for FCAT. All right, so our homework, which we'll move to quickly. Like I said, I already did a lot of these. Well, not a lot of them, but I did the ones I wanted to show you. So I'm just going to pull up, and here's where I already went through it, and I'm going to talk about this for us. All right, so here I have 4.4 liters, and I'm going to change that to pints. Now the first thing you'll notice is when we go to the reference sheet, right, we want to use our uh, metric to customary section here, right? Because liters are metric, we're going to change it to pints. And we notice that we don't have a liters to pint conversion, right? It doesn't mean it can't be done. We just don't have a liters to pint conversion. We have a liters to cups or liters to gallons, no liters to pints. So we need to think, can we get from cups to pints or from gallons to pints? And actually, we can do both. Cups has a direct conversion to pints, so that would make it a little bit shorter. And if we wanted to change liters to gallons, we would change gallons to quarts and then quarts to pints. But I say we change liters to cups and then cups to pints because it's shorter. Right? And as I show here, I point that here, liters to cups and then cups to pints. Right? And I change 4.4 liters. I put that as a fraction over 1. And then I multiply by another fraction with liters in the denominator. Right? Let me go ahead and just write this. I'll write it again. I just put 4.4 liters over 1, and then I multiplied by another fraction with liters in the denominator. Right? And I'm going to go from liters to cups, so I put cups up top. Now the reason I take it from the numerator to denominator is so that now I can cancel them out. Once it's in the top and the bottom, I can cancel that out. All right, and I see that I have 1 liter is 4.23 cups. That's what's on my reference sheet. 1 liter is 4.23 cups. Okay, so I just put that on there. Now, I don't know how to make this much easier. People will constantly put 4.23 down by liters, put 1 up by cups, right? You don't want to do that. It says, the reference sheet says 1 liter, 4.23 cups. That's where you're going to put it. You're going to put 1 next to liter, 4.23 next to cups. Dimensional analysis, that's what we're doing here. Dimensional analysis will put everything right where it's supposed to go if we do it right, okay? So now we can cancel our liters. We're going to change our cups to pints. So we're going to multiply by another fraction where cups were on top. Now cups are going to go to the bottom. And then cups will change to pints. Our reference sheet, we look. It says 2 cups, 1 pint. So 2 cups, 1 pint. And as you see, that's what I've done here. And our cups cancel, and now we can multiply it. 4.4 times 4.23 times 1. It gets us 18.612. And then our liters are gone, our cups are gone, our pints are all that's left. Then 1 times 1 times 2 is 2. We do that division. We get this, and then we get 9.306. Now our homework does say to round to nearest hundredth for number 7. So I'm going to underline the hundredths place, circle the place value to the right, and then 6 is going to make that 0 go up to a 1. Right? I do the same thing here, except for this one's a lot easier because I can go directly from hours to days. Right? I make a fraction, 60 hours over 1. I multiply by a new fraction that has hours in the denominator so that they'll cancel, and days are in the numerator. 1 day is 24 hours. Okay? Then we can cancel our hours. We changed hours to days. We already got there. And so 60 times 1 is 60 days, because that's the only thing left on top. And 1 times 24 is 24. And then I actually complete this division problem. 60 divided by 24 is 2.5 days. That was number 4. Here we're ordering each set of measurements from least to greatest. Let me get my toolbar back so I can use that. And I just in my head I did a little bit of comparing here. I compared my feet to inches. I know that 5 inches is going to be less than 1 foot. So I just did a little bit of ordering, 5 inches, 1 foot, and then I said I don't really know how they compared to the meters and centimeters yet, but I know that 1.1 meters is less than 19 centimeters. Why? Because 19 centimeters, if I move that decimal place over 2 times, because there's 100 centimeters in 1 meter, it's 0.19 meters. So 19 centimeters is more than 0.1 meters. So I just did that, in my head there to order things. But then I said, all right, well, I want to change all of these to the same unit. And I just picked meters. It was pretty arbitrary. I just picked it meters because I knew centimeters would go to meters easily. I knew feet would go to meters easily, and inches could go to feet, and they could go to meters. So I started with my 19 centimeters, and even though I already had it here, I wanted to show you how that would look with dimensional analysis. Okay, 19 centimeters over 1. 1, take that centimeters, move it to the bottom, put meters on the top. 1 meter, 100 centimeters. 19 times 1 is 19. 1 times 100 is 100. 19 divided by 100 is 0.19. Alright, so I put that there. My meters are already meters, so I don't need to change those. I'm going to change my feet. 1.1 feet. Feet goes directly to meters. Feet were on top, I put it on bottom. Feet to meters, right? I put in the conversions there, and I got 0.3355 meters. So I just go ahead and put it there. I meant to do this in purple. I said I was going to do it in purple in the other video, but then I picked red for some reason. So this is our inches to meters. And we know that there's no direct inches to meters conversion. We have inches to centimeters and we have foot to meters. But we already had, feet to meters. So I figured why not just take inches to feet. So this red here is actually our purple conversion there. So inches, they cancel, I move them to the bottom, feet go to the bottom, and then I have it all there. And there's my answer. Now, I put them on top of each other, line them up vertically here because that's how I like to compare numbers. And I look at my greatest place value first, and they're all zeros. So it doesn't help me. Then I look to my second greatest place value, which is the 10th place, and this is 3, and all the rest are 1, so I know that's greater. So I put my green, which was my 1.1 feet. That's 1.1 feet. That's the greatest one. And then I go to the next greatest place value, because these are all 1s, it doesn't really help. I go here, and I see that this one, I don't need to worry about it, but 0.19 meters, which was my 19 centimeters, is second largest. And then my 0.2 meters, which was my 5 inches, that's third largest. And then smallest is my 0.1 meters. Okay. Then the last one, and actually I told you in the first video I made that we don't need to know this until Monday. I don't know why. I think they may put this in here to kind of help spark your memory about things, because this was done in 7th grade, and you're in 8th grade, so you should remember a lot of this. But here they say the Earth rotates at a speed of 25,000 miles in 24 hours. So this is a rate, miles per 24 hours. Right? It's not a unit rate because it's not per 1 hour, but it's per 24 hours, so it still is a rate. And they want to change it to the unit rate of kilometers per second. Right? And I showed that to get from miles to kilometers, just miles straight to kilometers, but then hours, you have to change it to minutes, and then change it to seconds. And here, this first part is the same as what we've done. Miles are on top, they go to the bottom. Kilometers, we put in the conversion here. And then I said, we just hold on to this. We don't do anything with it yet, because now we want to change our hours. So hours were on bottom, so we put them to top, because I want them to cancel. Okay, so I just do that, I convert it. The minutes are on bottom, they go to the top. Seconds, and then everything cancels out except for my kilometers and seconds. Multiply across the top, multiply across the bottom, My calculator came out with this, which I just wanted to copy down here, and I'm going to round this to the nearest hundredth. It doesn't say to, the homework does, but we're going to find the hundredths place, circle the place value to the right. That 5 makes a 6 kilowatt. So 0.47 kilometers per second. This is 15 and 16 on your homework. I think no. 15 is actually just like the other ones. It's just in words. So don't let that scare you off. This is just like these, but it's in words. It's basically saying 26.2, which I think is it's a marathon. Miles is how many kilometers, right? So it's just like those. There is a direct miles of kilometers, round to the nearest hundredth if necessary. So this is the only one that was a rate, but you can do it. All right, I hope you have a good weekend. Stay safe, do good, avoid evil. Bye. I love you. Have a good day.